So for homework question 44 for module 8, they give us these 4 Lewis structures and ask for us to select the best Lewis structure for the atoms from the selection below. We can cancel out a few of these pretty quickly because, right, 2 things we want to work through. Number 1, does anything violate the octet rule? Once we establish that, the next thing we want to do is figure out what is my formal charge, because I want to have the fewest atoms carrying formal charge whenever possible. And if I have to carry a formal charge, I want it on the most electronegative atom possible, right? If I have to carry a formal negative charge, I want it on the most electronegative atom. So right off the bat, we can cancel a few of these by looking at the octet rule, right? If I look at this carbon right here, this carbon right here, it's got 1, 2, 3, 4 bonds and a lone pair of electrons, right? So that's got more than an octet. That's got 10 electrons assigned to carbon. That's not good, right? Carbon doesn't want to have more than 8 electrons. Carbon only wants to have 4 bonds. So we can get rid of that one. That's not the best Lewis structure drawn. And we see the same thing down here, right? If I look down here, again, I broke the octet rule for oxygen, right? Oxygen only wants to have 8 bonds, or 8 electrons. This one's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 4 bonds and 2 lone pair electrons. So not so great for that Lewis structure. So I can cancel out both of those Lewis structures because we broke the octet rule. The next thing we want to check is our formal charge. That's going to help us figure out the most correct Lewis structure here, right? The remaining 2, I haven't violated the octet rule for anything here, but we do have different formal charges, right? So for this one, hydrogen is group 1, and all of the hydrogens in that structure have 1 electron assigned to them, so they're neutral. All right, carbon 1 and carbon 2 are the same, so we can answer both of those, right? Carbon's group 4, and both of these carbons have 1, 2, 3, 4. 1, 2, 3, 4 electrons assigned to them. So 4 minus 4, that's neutral. Oxygen is group 6, and this oxygen has 1, 2, 3, 4, 5, and 6 electrons assigned to it. So 6 minus 6 is neutral, right? I think we have our answer, but we can go do the other one as well. And remember, to count formal charge, we count all non-bonding and 1 electron for each bond. So that's why I counted 6 total electrons here. 1, 2, 3, 4, and then 1 electron for each bond, 5 and 6. So far, so good. Everything in this structure is neutral. But let's just check the last one to make sure. Right, hydrogen is group 1. It's got 1 electron assigned to it, so that's neutral. Carbon is group 4. However, this carbon has 1, 2, 3, 4, 5, 6 electrons assigned to it. So 4 minus 6, right? Minus 2 charge there. And for my oxygen, oxygen is group 6, and we count 1 electron for each bond. So 1, 2, 3, 4 electrons there. Right, this oxygen would be plus 2. So 2 things, right? Number 1, we want to have the fewest number of atoms carrying charge. So that makes this Lewis structure the best Lewis structure because we haven't violated the octet rule. I have the fewest number of atoms carrying charge, right? No atoms are carrying charge. However, down here, I've got 2 atoms carrying charge. So I've got more atoms carrying charge. And the other thing against me is that if I have a negative charge, I want it on the most electronegative atom. So oxygen is more electronegative than carbon. So if I have a negative charge, I should want it here on the oxygen. It's not. It's here on carbon. So that makes this structure, for a couple different reasons, the best Lewis structure of those listed in that series.